Kia ora tātou, welcome to the Level 2 Mechanics 2023. Paper's just been released online, so I'm going to go through it. Okay, so question 1 about a softball match. A stationary player accelerates from home plate to first base, the player takes yada 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 yada. Okay, so we're going to get, for question 1A, 6.61 seconds, 5.45 meters per second. You're going to recall that acceleration is equal to change in velocity divided by change in time, which is equal to 5.45 divided by 661, and you should get 0.825 meters per second. So it's a pretty nice, easy proof question right off the bat. Just getting my formula sheet out. Right, okay. I wonder if I can lock this in position. Probably not. Calculate the maximum displacement. So we had time equals 6.61. Velocity final is equal to 5.45. Acceleration equals 0.825. Now, the problem with this question is there are two theoretical answers. The first theoretical answer is if you just sub directly into the formula sheet, and you're going to get distance is equal to which one do you want to use? VIT plus half AT squared. Yeah, we can do that. VIT is just 0 half times the acceleration times the time squared, which gives 6.61 squared times 0.825 divided by 2 gives 18 meters. Now, I suspect that's the correct answer, but you could also make the case that they could accelerate instantaneously, so they're traveling at 5.45 meters per second the whole time, which would imply that distance is equal to 5.45 times 6.61 equals 36 meters. So both of these, you can make an argument for both of these, which means the question is worded pretty awfully, if I'm honest. So, but it's just a merit question, I think. Okay, why might this displacement be different from the actual distance travelled by the player? The acceleration is not constant. And you know, you can waffle a bit, but that is essentially what they want you to say. Oh, is this just B2? Whoops, B2. Okay, C 0. I wonder if I can I do it this way? Oh, good, I can do this. Okay. 0.18 kgs, kg, 44.4 meters per second, and it takes 0.51 seconds. Okay, that's good. What does the term impulse mean? Well, we'll get to that. These are our terms here. So the term impulse is the change in momentum divided by the change in time. So the impulse force is a force is equal to change in momentum, which is 0.18 times the 44.4 divided by the 0.51 seconds, which is equal to 0.18 times 44.4 divided by 0.51 is equal to 15.7 newtons. Yep, I think that's it. Cool. We're gonna want, okay, and then explain why the padded glove is useful. Compression of the glove increases the change in time, therefore the impulse force is lower. Again, expand on this, right? Mention delta P is constant, that's not affected, it's not increased or anything. So yeah, it's not too bad. And then the last question, the actual question D, this is just CII. Question D, probably the easiest excellence question, but easy to get wrong. You got 50 kilograms going at whatever that speed is, and you've got 60 kilograms at 0.4 meters per second this way, and then after the collision we're going at this direction, 110 kilograms times, what was it, 2 meters, which equals 220 meters per second. Okay, so that's pretty poor, 20, but yeah, 220. Okay, so the momentum after the collision is just 220 kilogram meters per second. The momentum before the collision is 50 times this velocity minus this momentum. It's not addition because it's moving in the other direction. Minus 24. Therefore, this is going to equal about 4.9, I think. 220 plus 24 divided by 50, yeah, 4.9. And that is the answer. What's it doing? It's running a new page. Oh, for God's sake. Good, there we go. And my momentum's conserved. Yep. Cornering, calculate. A player with mass. Okay. Do it on this one again. So we got 55 kilograms, 7 meters per second, 15 meter radius. What does this equal? Okay. So that's all good. So question 2A, force centripetal is equal to mv squared divided by r, which equals m 55 times 49, because that's 7 squared divided by 15, which equals 55 times 49 divided by 15. That's going to equal about 180 newtons. Okay, question B. You got your track, and there's this guy running on the track. So he's going to have a velocity this way. Well, okay, don't get thrown off by the vector arrow. I won't bother. Velocity is going to be going this way. The acceleration and the force are inwards, and there's also an outwards friction force, sometimes called centrifugal. I don't know whether they want you to put that in the diagram. I probably wouldn't bother, but weird one. Anyway, that's that diagram. Explain why the plane can be moving at a constant speed and yet be accelerating at the same time. The first bit was friction. Why can they be accelerating but moving at a constant speed? Is a vector always changing direction? To change this, we need acceleration. Therefore, it is proven / explained. So velocity is a vector. It's always changing in direction as you go round. You know it's going to go like this way, and then be up this way. To change this, we need to accelerate. D, so suddenly they run into a slippery part, which is going to cause them to... Okay, they run into slippery patch of mud. Okay, so this means that the centripetal force is lowered, the radius of their path is increased, mv squared is constant, and if friction is completely lost, Fc equals 0, and they move tangential to the circle. Okay, once again, expand on that slightly more. I am shorthanding this because I'm not going to bother writing the long-winded answers when you just need the key, but these are the key words that you say, and then you just waffle a bit around it. Question 3, projectiles. We've got, this is 22, that's 30 degrees. Show the vertical component, the initial velocity of the ball. This is 35, whoops. This is going to equal the vertical component, velocity vertical, and that equals 22 sine of 35. We're using sine because we've got the opposite side in the hypotenuse. I mean, it is a show question, so you could just test and see which one works, sine or cos. But you're going to see, as long as your calculator is in degrees, that you get around about 12.6 meters per second. Oh, what the hell, what's that? Okay, don't want that. Calculate the maximum height the ball reached above the ground. So I'm gonna, like this, we know our velocity initial is 0, we know velocity final, no we don't, no that's wrong, I did it completely. Velocity initial is 12.6, velocity final is equal to 0, acceleration is equal to minus 9.8, and distance equals what? Okay, so you sub into a formula of your choosing. Looks like we're going to use Vf squared equals Vi squared plus 2AD, so 0 equals 12.6 squared plus 2 times minus 9.8 d, hence 2 times 9.8, 19.6 19.6d is equal to 12.6 squared, 58.76, so d is equal to 8.1 meters. Okay, but the question asked above the ground, and you got to remember your batter's at 1.6 meters up already, so you add 1.6 and you're going to get 9.7 meters. That is the answer. velocity, the ball's motion can be tracked. Okay, so the force is acting on the ball. So you got your thing, you got this point here, and this point here. The force acting on the ball is just gravity downwards. That's the force acting on the ball. Okay, so when it says describe and explain, the force is constant due to gravity. Acceleration is constant, 9.8 meters per second downward. Horizontal velocity is constant. You could even give a figure. It's going to be 22 cosine 35. Probably not necessary. At 18 meters per second. And vertical velocity, this is one, vertical velocity changes due to gravity. Force is constant, acceleration is constant, horizontal velocity is constant, vertical velocity changes due to gravity, and that makes sense because it looks like that's the only thing that's changing is the only thing that's changing at a non-linear rate is the height. That's not it's not linear. Everything else is linear. So that's that. Okay, and then what many people will say is the hardest question, bit of a tricky talk question, but let's go through it. We've got our bench. This can be support force A. This can be support force B. Okay, so this distance is 0.6. Now there's a coach here, 110 kilograms, and there's a player here at 74 grams, and there's forces. There's a weight force from the coach, a weight force from the player, a weight force from the bench, and 2 support forces. This support force will be slightly larger because the coach weighs more. Well, the coach is closer than this player, but I think it's going to be of a pound. This distance here is 0.35. This distance here is 0.42. And this distance here is 0.3. This distance here is also 0.3. Okay, now we need to work out the forces. This is 110 kilograms times 9.8. It's 1,078 newtons. The bench weighs 40 kilograms, so we're going to have 40 times 9.8 equals 392 newtons. 74 times 9.8, 725.2 newtons, and we don't know our 2 support forces. So, if I put A and B around, I put A and B around the wrong way. Whoops. Let's not do that. This is A, this is B. Okay, now we're going to pivot around point B. And remember, the sum of the torque is equal to 0. And torque is a vector, so all that means is the torque clockwise is equal to the torque anti-clockwise, always. So, let's pivot. This will cause clockwise, likewise this will cause clockwise, this will be anti-clockwise, this will be anti-clockwise. So, torque clockwise is equal to the 725.2 newtons from this player times by the distance that player is away, which is 0.42 meters, which is 304.584 Newton meters, plus this force here. Now we don't know what it is, which we're actually solving for it, but it's equal to force A times the distance between them, 0.6 meters. Now, torque anti-clockwise is equal to the bench dragging it down, 392 newtons times the distance, 392 times 0.3 is equal to 117.6 newton meters. And this, the coach, 1078 newtons times the distance away, which is a bit tricky, but 0.6 plus 0.35 is the total distance away. 0.3, 0.3, 0.6 plus this 0.35, you get 0.95, hence that is 1024.1 newton meters. And now you make these equal to each other. So 304.584 plus 0.6 times that support force is equal to, I'm just going to add that up in one go, 1141.7. Okay, rearrange, you get 0.6A force A is equal to that minus 304.584. 837.11. So I'm just being exact until we get to the right answer. Force A is equal to that divided by 0.6, and you should get 1395.19, which is equal to 1395, which is 1,400 newtons to three significant figures. I mean, this is technically two, isn't it? But yeah. Force B, now to calculate force B, all the upwards you could just pivot around this, you get the same answer, but that's a bit long. All the upward forces equal the downward forces. So that means that the 1078 from the coach plus the 392 from the bench plus the 725.2 from that player is equal to the two support forces. We already know one of them, we've just worked out one of them, 1395 plus force B, which implies 1078 plus 392 plus 725.2 minus 1395, you get 800.2 is equal to force B equals 800 newtons. So your two answers are 800 newtons and 1,400 newtons to 3 SF, because that's what you were given in the question. You probably wouldn't lose any marks for writing that, that's good enough. Okay, and that, ladies and gentlemen, is the paper. 23 minutes, whoa, it's a good speed run. Of course, I haven't actually written out my word answers completely. So, yep, that's all good. I'm going to do electricity next.